All right, so we got lesson 9, Introduction to Trigonomic Functions. All right, an angle of a circle. So suppose point P is on the unit circle at 1 comma 0. Okay, right there. And describe the x coordinate, so the x value, as P changes as it rotates around counterclockwise. Okay, around the circle. So it's going to be moving this way. As it moves that way, the x value decreases, right? It goes all the way over, like once it hits here, your x value is now 0, right? Who cares about your y for now? And then eventually it gets to here, and now your x value is -1. And like, let's just not care about your y for right now. Okay. And then as it keeps going counterclockwise, it'll be over here eventually, and you realize your x is back to 0, right? And then eventually, as it keeps going counterclockwise, it comes back over to 1. All right, so that's something that's happening with the x value. Now, what about the y value? Your y value starts, so x, um, your x value, so number 1, the answer in reality is that uh, your x value, as it goes around counterclockwise, it starts at 1, right? It goes to 0, then it hits -1, then it gets back to 0, and then it comes right back around to 1. Now, what about your y value for number 2? Okay, we're still doing the starting at p. What's your y value? 0, right? So now we're worried about the y value. What happens when it goes up over to uh, this coordinate, right? What happens when it's over here on that coordinate? What about over here at the 270 degrees? What about when it comes back all the way around? So hopefully you realize just going around counterclockwise, your y value, when it gets up to the very top, right, at 90 degrees, becomes 1. And remember, 90 degrees is the same as saying pi halves in radians. And then when it gets over here, right, on the 180 degrees, all the way over on pi, your y is now 0 again. Um, and then what about here? And you should realize it gets to -1, and then eventually comes back to 0, right? So that's just something you should be noticing as you go around on your values of value p or coordinate p. All right, do the wave. So go ahead. You can use Desmos totally, and you can totally type this in. Um, if you have issues with theta, you could also use x in Desmos, and you should get the graph for that. You could do the same thing as well for number 2, and you should see some waves, right? What do you notice about the two graphs? So definitely compare the two, okay? And explain, so number 4, explain why the angle measures between 0 and 2 pi gives a point on each graph. Hmm, okay. Could these graphs represent functions? Explain your reasoning. Hmm, okay. So go ahead, try that on your own with Desmos. Graph those two functions, cosine of theta, and you could use x in Desmos and you should be fine, okay? And then graph on a separate line y equals sine of x or theta if you don't have problems with theta. Okay, so what do you notice about the two graphs? And explain why the angle measures between 0 and 2 pi gives a point on each graph. Could these graphs represent functions? Explain your reasoning. Okay, so one thing that I'm going to be operating with. So number 1 is the graph for cosine. Now let me explain what's happening with this graph and how it's related to the unit circle. So cosine of x, right, was the first one. Let me use a neutral color here. So hopefully you cosine of x, right? I think theta would have given you an issue on Desmos. Then we'll use the green highlighter, okay? So cosine of x. Now remember, cosine is the x value, right? So the first value, and remember p back in the first example, it's very similar to that, okay? Because we're talking about the unit circle. So you start at 1, right? And then when you go up to pi sixth, your x value is now that, right? So, and that's 30 degrees, okay? Um, when you get to pi fourth, you get to this value, which is right here. When you get to pi third, so notice you're getting smaller and smaller. You're going down, down, right? So that's a half. And let me go ahead and kind of write it in there, right? That's definitely a half right there. So, and eventually, when you get to pi half, you get to 0, right? And an interesting thing occurs is you start getting closer and closer to the negatives, right? You get more negative as time goes by. So negative, so with 2 pi thirds, you get to negative 1/2, which is right there. I'll go ahead and write that in. All right. And then you get smaller and smaller, so 5/6 it's right there. And then you get to negative 1 all the way here. And then you make your way back up. Your x values start coming back up, right? So negative 1/2 comes back up right there. 5/4 was what? Right here. And 7 pi 6, 5/4, right? And then you get back to 0. And then you start making your climb. That's a half, which is right here. And then you start getting bigger and bigger. So 7 pi and 11 pi. So right here and here. And then you get all the way back up to 1. So notice the travel that we're going, right? So your value gets smaller, 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 smaller. It gets to negative 1, and then it comes back up. So we literally are graphing on a Cartesian plane in radians uh, what what it's like to be going around a circle. Okay, and of course it's a cosine, so we're only focused on the x. Now, what if we were focused on the y? Okay, on the y aspect, that would be with sine. So versus y of sine of x. So let me zoom out a little bit. Sorry for those who are going to have trouble seeing this. And let me pick a decent color. Aqua. We'll use aqua. You guys remember that band? All right. So sine of x. And again, we start at 0, right? Boom. And then we go up. We're increasing. Okay, so pi 6 is already a half. Okay, and I'll go ahead and write that right here. That's a half. And then, of course, later on, might as well get the uh, negative half written out as well. All right, and then eventually you get all the way up and you get closer to 1, and then finally at pi halves or 90 degrees, you max out at 1. And then you go counterclockwise and you start getting smaller and smaller and smaller and then boom, you go right back to 0. Boom. Okay. And then you go way smaller. You get negative, in fact. You get lower and lower into the negatives until finally, boom, max out at -1. Okay. And then, of course, you start climbing your way back up, cross -1/2. And then when you get all the way back up, you go full circle and you end right back where you started at 0. So circles, when you graph them, are waves, which is interesting when you think about gravity, when you think about our planets, our orbital patterns, and even the waves generated by the moon's gravity on our oceans. It's fascinating. Even sound waves, uh, spectrums of light, they all go through a certain frequency. They all have their different amplitudes, and all you're really seeing are just waves of light and sound. So it's fascinating. Everything kind of gravitates around this in some subliminal way that most animals aren't even aware of. Okay, so what again, going back to these questions, um, what do you notice about the two graphs? So compare the two. Okay. Number 4, explain why the measures between 0 and 2 pi give a point on each graph. So um, were we going by 30 degrees? Let's just look at the graph, not the circle. Let's look at the graph. Were we going by 30 degrees or were we going by 15 degrees for each time? Okay. So that's just something I want you to kind of look at here because theta are your degrees. Okay. And let's see. Could these graphs represent functions? And that comes back to me talking about sound, light, spectrums of light. Um, a physics class will definitely go into this. Calculus, especially. A lot of sciences are based upon these ideas um, because you have so many technologies that measure these things. Um, sonograms, radiology. There's a lot of sciences connected to the medical industry that are based upon these things. Engineering, electricians, they literally have an inverter, a power inverter um, that uses pure sine wave. So yeah, it's that common in your fields, even in consuming products. All right, so graphs of cosine and sine. This is a nice one that you can do with Desmos. I highly recommend you using Desmos for this activity. Type each one in. You should see something like this, but I really want you to go step by step and figure out which one is which. And also, what do you notice between the red wavelength versus the green wavelength? All right, which one has a tighter wave, if you will? Okay. What do you notice about the amplitudes? Okay, so amplitude, right? There's the amplitude for that one, which looks like the amplitude is just that big. But what do you notice about the amplitude of the red one? Okay, and why are those amplitudes different? Okay, which one is sine, right? Which one is cosine? That's something else that you can also look at. So go ahead and use Desmos and graph those. And I also want you to look at number 1 real quick. And they say uh, what values uh, are there when cosine and sine are the same? So if you look back up here at the unit circle, there are two possible answers. When is cosine theta going to be the same as sine theta? So when is your x and when are your y's going to be the same? Okay, so hopefully you paused it and you looked around the unit circle and you realized pi force, right? Your x and y are the same. And then 5 pi over 4, your x and y would be the same. Okay, so that's something to consider there. Notice how quadrant 2 and quadrant 3, these two do not equal the same because one's negative and the other one's positive, right? As is this one here. So quadrant 1 would work, quadrant 3 would work, but that's only because the x and y's are both positive or both negative. Okay, so that's your answer for the number 1. Okay, all right, so in the end, the lesson summary is basically this: cosine of theta, right? You start at 1, sine of theta, you start at 0. What do you notice, by the way? Um, a full circle is from 0 to 2 pi, right? Where are you after just one rotation or half a rotation of a circle, right? You're at -1. But for sine, half a rotation, you're at 0. Okay. Are their amplitudes the same? That's another thing to think about. All right, so that is basically the summary of the lesson. So have a beautiful day. Make sure you do your practice.